Hi, everyone. Okay. The title of my talk today is Functional Programming in UI and PSW, bracket sort of. I'll explain the acronyms later. Yeah. So, hi, I'm Ken Ding. I said that this year. Things to know about me. I'm a UI enthusiast, and by UI I mean user interface, if you're not already familiar. I'm an FP fledgling. By FP I mean functional programming. I hate complexity. I really hate complexity. I work in a tribe called PSW, which stands for Property Search and Web. We're a really cool tribe. All right. Motivation. Why am I giving this talk? I think my goal of this is to kind of prove that functional programming is possible in JavaScript. You don't really need all the tools. It would be better if you have a type checker and cool stuff like that. And we do use it in our code base, but it can be done just with pure JS. Like it's the way of thinking, right? So you can consider using FP if it applies. Oh, I said they. I don't know why. And the purpose of this talk is not to alienate you if like you're a UI dev or if you're an FP like person. I don't want to alienate you and kind of make fun of you or whatever. And this talk's not about functors or monads or monoids. I think they're really excellent concepts and you really should spend time learning them. But like this talk's not about those concepts. And just a warning, we do use static type checkers in our code base to like ensure that when it's a when you map, it goes from A to like an option B or something, A to B and stuff like that. But this talk's not gonna show too many examples of that because like we just want to demonstrate that the concept rather than the actual implementation. If that makes sense. And the cool stuff, I'm going to show you like real-world UI problems that we've solved in the property listings web in our code base. And these are like actual, for me, it's like real unique UI problems that I think we solved in a good way using functional programming. And I think that's really important. All right. All right. But before I jump into like all the use cases that we have, I'm just going to like lightly do a shallow dive into functional programming. I'm not going to go through like the whole thing because like it's really hard. And this is important. If you get a CSS reference, like important. For me, functional programming is all about pure functions. And by pure functions, I kind of relate it back to like high school when you had this diagram and you had like every input term is exactly one output term, and you would kind of in your exam you would have this diagram and you say, is this a function? Yes, it is, because it maps to exactly one output. And then this is not a function because one input term could potentially go to two different outputs, right? So that's not a function, so therefore it's not a pure function. And if you kind of reword that, a function's output must always be the same given the same inputs. A random stranger told me on the tram. Actually, that's not really true. But I thought it was funny. And like another concept in functional programming is like you don't want to have side effects. So like making a HTTP network call, a database connection, or printing to screen, or Bitcoin mining when you're making a function call. That kind of could affect what the output is, and therefore it's not really a pure function, I think. Yep. And when people say no side effects, when I first learned about like functional programming, people were talking about like, don't have side effects and don't do anything. And I was like, well, what do you really mean? Because like we need to write like real code that actually works, right? And I think like it took me a while to realize that actually what we mean is really isolating the side effects. So if you push your side effects to the boundary, like maybe a lot more of your code can be tested. So like a lot more of your code is predictable. And this is a GIF about someone pushing the person to the side. They're pushing it to the boundary. It's just funny. All right. All right. And I think I'm not going to go through this, but like for me, a good functional programming has like well-structured data and well-specified functions that transform that data, and that's slightly different from an OOP way of thinking where you have like good objects and then with like clear methods on them and stuff. But we'll get to this later when we go through our examples. All right. Problems we face for Rails. So one of the things when we were building, like when we were doing ByX or ByReef platform, is that we use a GraphQL API, and it's called Lexa, Listening Experience API. It's in production. It's really cool. There's like heaps of good thinking behind that. But from the UI perspective, we needed to handle errors from a GraphQL API. And for your context, and this is important, like I'll compare this with like a RESTful API. So for a RESTful API, if you kind of make, like this is an example to listing services where you request a listing ID, and if it's successful, you get a HTTP code of 200. That signifies a success, so therefore you can render your code. That's cool. If you request something that doesn't exist, like for example, I just chucked a B at the end of the thing, that means that resource doesn't exist. The server would then return you a 404, which indicates not found. And that's really clear. That's like a one-to-one mapping. And if it's a server error, it should return a 500. I don't have an image for this, so you can kind of reimagine it. Get it? All right. So for GraphQL, it's slightly different. For success, it's still the same. Like if this is a client that we use called Graphical or GraphQL. If you pronounce it that way, that's weird. Yeah, but if you request it, you get like a response similar to this. Can you see my mouse? Yep. And you still get a 200. But if that resource, for example, if that listing is not found, we still return a 200, except that like the response is now null, because there could be other parts of that query that return successfully. So you don't want to just show 404 when other parts of that response can still be used. And same for oh, that should be 500. Wait, actually, no, it's correct. Error HTTP 200. Yeah, so we simulated an error here. That's a cool thing. I think it's called a directive. You can simulate error, and you would still have like a listing null, but you get an errors array back from Sangria, which is the library that we use for GraphQL in Scala. I got it right. You would get back an errors array with like information about where that error came from. So for example, this details listing means that it came from like, this error comes from details listing. So this is a nice comparison, like, you know, it just means that for GraphQL, it's not really that simple. If some part of your data doesn't exist, then you might still get a 200 response back. And handling errors should be like your priority as well if it's a UI dev, because you need to think about all the scenarios that could happen. So I'm going to show you some code now. This is an example from what we get back from the server. So you get a data with a listing AB and an errors array with a path of listing. This is not the real response, but I've kind of like simplified it a bit. And I'm not going to like jump into this whole thing and explain how it works, but if you look at the code here, you will realize that this code here to handle the error is extremely specific to the details response. So if you go to the details page and you request a specific thing, this error handling logic has to check like if it's details listing, and it's very specific to this response only. And this is sort of okay. Like this code's not good. It's okay if the logic was confined to a single module. Said Mehdi and Grantos. Mehdi and Grantos, like the lead devs of our teams. It's a photo. And this is like Mehdi and Grant just like looking at the code. This is okay, I guess. But the problem is, it's not really confined to that module. So to give you some context, we fetch the data on the server and on the client, and when we fetch the data, we get back the response in a promise, and in that promise, that's where we get the response, and only then do we know, only then can we check the errors and determine whether or not it's a 404 or 500 or whatever. So this is a nice diagram I drew, and this is on the server side. I'll kind of, text is really small, and it's universal, it's really cool. Okay, the Express middleware is like a Node.js library, and it's at this point where we can define like here return a 200 HTTP or like return the response with a 404, and it's at this point where we return the response codes and handle errors. And this actually calls fetch data, which is like this delegator thing, and then it calls to the root specific fetch data. Like it doesn't really have to make sense, but like, you don't have to understand how this works, but the difference here is that we know that it should be a 404 or 500 at this point, at this part of the code in the root specific fetch data, and we return the response code at this level. So they're like very, very far apart. I'm going to show you some code. So if we were to write like the fetch data in the Express middleware, and we wanted to like know really specific things, one way we could do is to write like to reach into the data when the fetch data returns, and then kind of check like, oh, is it a details page? You know, is it a 404 on the details page? Is it like a server error on the details page? It's very specific. So for example, if something on the details page was wrong, and it could have broke the results page as well when it didn't have to. So that's no longer really okay if the logics confine to single modules. So like many grants weren't really happy with it. We thought for a second, what did we really need? And like, we thought about it really hard. Because what we really needed was software and hardware. Okay, we needed to tell our middleware that it should return a 404 or 500 status code without exposing any details from the response, right? That's what we needed. And to solve this problem, I need to pause and rewind back to the winter of 2016. This was back when, like, I think Mehdi introduced options and either types to our front-end code base. And I'm not going to like jump into the full implementation of it, but like from a high level, an option type, when you say something is an option type, it could mean two things. It could either be a something or a nothing. And if it's an either, it just means that it could either be a left or a right. And each of them wrap the data, so they describe the data that it contains. This is like a couple of nice tables that I drew. Yeah, like the difference between option and either here is like your data could be a sum or a none. Either could be a left or a right. And I was told to change this slide, but I didn't really. So for an option, a sum means that it's not a null or undefined value, which means that it could be a 1, like an integer of 1 or a string of a or something. As long as it means something, it is an actual value. And a none means that it's null or undefined. It just symbolizes what it contains. And either means that you're right. If it's a successful value, you normally wrap it in a right. And if it's an error, you wrap it in a left. And for me, I think I decide when to use them. Like if I don't care, if all I care about is whether the data exists or not, I use an option. If I care enough to kind of pass through contextual information, I use an either. So I'm going to show you some code. This is not real code in production, but if you wanted to implement your own option type, you could do it. And this doesn't have types in it, but like this is kind of like, all I want to demonstrate here is that a sum and none both implement the same interface. So if you call a map on an option, it should both be implemented on the sum and none. So initial thoughts when this was introduced. I was like, I don't really like this, because it was like back when I was young and stuff. And I think I had a lot of comments on that PR, and I think it was up to 40, like we had a total of like 40 something comments where everyone was like, why are we doing this? Why? And Grant had this funny comment. And like my initial thoughts were like, why are you adding unnecessary abstractions to like a UI code base, right? This feels very like an extra level of abstraction for us. And like, why not this library? Why not use Lodash or this other cool library that I'm already familiar with? So now I'm going to unpause and like fast forward back to this point when we needed to tell our 404 or 500 without exposing details, because like this is a perfect use case for that. So this is the example where when we handle the error, we return the error wrapped in a left, or if it's a not found, we return it wrapped in a right of none. So right means successful, none means doesn't exist. So it successfully return you nothing. Or if it's successful, you just wrap it in a right of some. And this is a nice diagram I drew. So like, yeah, what I said just now, if it's a left, it's a 500. If it's a right of none, it's a 404. If it's a right of some, it's a 200. So this is the fetch data return type. And if we kind of refactored our code just now that we saw in the express middleware layer, now we don't have to reach into the data and figure out what exactly is in there. All we need to know is like the return type is like an either or left of app error and right an optional data. So all you needed to do was fold on it and kind of handle the error right there. So it was really cool. So that was when I was like, yes, this is great. I was the gorilla, and options and either's were the shark. So we high-fived each other. It was cool. And I foolishly thought, this return type satisfies all of our use cases. All of them. We will never have to change this code ever again. Until permanent redirects came into the mix, which was, I think, like a few months back. And that was when we needed to kind of handle, for example, if a listing has just been marked as sold. So if you went to this URL, and if it's just been marked as sold, we wanted to redirect the user to the sold part of the website, so we needed to add like a /sold in front. So yeah, that's when I took a deep breath. I wasn't too angry about it, like I wasn't too upset. So like, what did we really need again? So now we need to tell our middleware like that it should return a 404 or 500 or 301 now. So like that's another thing. And I'm not going to jump into like the whole thought process and the implementation details, but what we ended up doing was not using an option in either, but we kind of extended the way of thinking, like wrapping our data with sensible wrappers. We said, why not create a custom type, a custom response type that signified either success or not found, a permanent redirect, or a server error. So when we refactored our middleware, it kind of looked like this. If we fold on the data, if it's not found, you just handle not found. If it's server error, you just handle server error, and all that cool stuff. So what did we really do here? We defined well-structured data, and the data represented what the values contained. And we have like heaps of other cool examples where we kind of use this way of thinking to solve UI problems. One of it was the partial data loading in our code base. So like when you click on a listing on the results page and we want to have an instantaneous transition to the details page, we kind of rendered the page immediately with the data that existed while we kind of secretly went off and fetched the rest of the data. So that was really cool. And we kind of also solved maps on the details page, like where we had to make asynchronous requests once the page has been loaded. So it looks very simple, but it's actually really complex. Lessons learned. Okay, types are awesome, but flow type is hard. Millie wrote this a while ago about how like sometimes you get weird errors coming up and you're like, why is this happening? Yeah, flow type is hard. But I think what I got out of it personally is thinking in terms of types. Like when we think of a problem, like sometimes we think of input and output. And like when you think in terms of types, you can kind of, without diving into the implementation itself, you can kind of like figure out, oh, what does this object look like and what should the output look like? And we kind of iterated on that based on thinking in terms of types like this, and we finally ended up with response and stuff like that. The other thing I kind of got out of this was to kind of apply concepts in moderation. You don't want to kind of like go to like a category 5 kaiju on all the concepts that you learned, right? You don't want to go crazy on that because you have a team to think about. They are really cool concepts, but you kind of have to pace yourself as well. Don't let an idea get in the way of good software design. At the end of the day, I think we all want to write maintainable software. We want to write good code. We want like separation of concerns and single responsibility principle. All of these things still matter to us, and that I think at the end of the day, that's the most important thing. Conclusion: write good code. Yeah. Questions?
Thanks, Ken. That was great. Quick question about flow types. How hard was that to configure flow types when you were recreating your functional types? You went from ithers and options to that list of 4 custom types you had listed there. Did flow work nicely with you? Did it cause you more headaches? Was it? Did it save you problems?
That's a good question. I think it didn't cause me that much. It didn't cause us that much of a problem because most of the time the problem with flow types is that we typed it wrong in the first place. Like, or in some parts of the code base we kind of typed it with any, where it just meant like you can do anything, and then you can't. So when we were defining these custom types, we were defining new types, so they kind of worked the way we expected. So yeah, it was pretty cool.
Cool.
What a good check mark. So we're in the same team, Ken, so I should probably know this. But how actually did the decision to use Flow come into the codebase? Or how does a team make that decision if you want to be more general about it?
I think there was a person a long time ago who was left, and he kind of championed that the Flow, introducing Flow to the codebase. And I think he started off with like one part of the code base, and then he gathered the team and everyone had like a discussion around like why we should and shouldn't use it. And it sort of started getting adopted more and more. So I don't really have a clear answer because I was only around for like, I was like at the sidelines and like criticizing Flow, but like, no, I liked Flow, but yeah. Cool.
So I really like the way you modeled the response objects there. You mentioned at the end about how you did something similar with the different UI states. Mm-hmm. Was that modeling a similar thing? So you basically you model the different types for different states that UI can be with the data that's associated with them? What did that look like?
So, like for example, we modeled it this way. We said like, on the details page, the data could either be full details or partial details. So when you come from the SRP, when you come from the results page and you transition to the details page, if it hits the cache, which is like the Apollo thing that we have, if it reads the cache and it comes back with that only that part of the data, then we kind of wrap it in the partial details. And then we had helper methods that looked at which operated on this data type, which we call it details data, and it said if it's a partial details, only render above the fold. Don't render the parts that require the data that still doesn't yet exist. Yeah, so we kind of modeled it that way. Cool.